Okay, welcome again to Wickerson Studios. Another big intro of okay and all right. We're going to try and make a little tiny fancy introduction soon enough. What I'm showing you here today is basically this little um, inspired by, I thought I'd pair it with the chapter 6 of the Tao Te Jing, this version. But basically, I've been cutting down a lot of trees in my forest and building a pawpaw fort. And I thought the tree design was kind of interesting, the way I use the larger branch and then break off the smaller ones as I go. Um, it's a pretty parametric model of, you'll see there's a lot of wires down there. Ignore that for now. The reason I've done this way and not called upon a plugin, Anonymy or Hoop Snake for recursion is I'm building these files on my Macintosh computer and using the very basics of what Grasshopper gives you. You'll see here I've imported it into my Windows, so I have a lot of plugins at the top. But I'm trying to make these scripts so you don't rely on anything, and I can do it in a Rhino 5 or a version or a Grasshopper version on Rhino 5 on Mac anywhere I go on my laptop. Anyhow, this script's pretty easy, and I'm going to break it down. Basically, I build a point from point 0. I move that in the XYZ direction. I then build an arc out of that. I also build a small rectangle, but I populate that with points. And then I'm going to basically pipe that arc, so take that arc and pipe it with a variable pipe, which is controlled by the gene pool, which is a selection of the parameters along the length of the curve paired with a radii, which can all be altered independently. And extremely parametric model. I think it's really fun to have. And then what I've done is I've scaled that down in a scale non-uniform because I wanted my Z and X and Y to be different. I did take from this surface a surface edit, a evaluate surface, and then I am orienting. Actually, I'm rotating the geometry of the smaller scaled version into a different direction, so I have control over that. But I'm orienting basically these points right here onto the points that have been oriented onto the evaluate surface points on the tusk, which allows for you to put all of these little guys on top of that one. I hope that makes sense. And then basically I've got boundary representation and I'm bringing them together. And that's it. And you've got a pretty awesome model. And even though the other stuff will slow it down, and I do like to put on my my canvas widgets, my profilers on, you can see that this one slowed down to 611 milliseconds. There's all these other wires down here doing something, and it's like, what have I done? But basically, I have really nice control over this. Not only changing the radii and the points along the curve to actually, start to play with. I have to keep that one in order. You can see that I can start to play with just the radii on those. But here's really where it comes in. Your X, Y, Z scale all the way down here, and then your number of iterations. You can see it moves a little slow, so it'll go down to 7. I can bring that up to 9, 10, 11, 12, 14, 13. And then I've got my X and Y bending and moving. And you don't ever want to flatten it out. You want to give it a ton of nice curve. Slowish kind of script because I've got 2 recursion loops scripted into this. So it's not actually using a recursion plugin. So that's where it gets interesting. Basically, I was just showing the script is basically the script. You can copy that out. You don't have to worry about all these wires. You can just take it right through and then do a Boolean union. But what I've done is I've then taken an iteration here, and I can apply that and activate that one. And you'll see in activating that one, I've brought a lot more power back into it. And here's your iterations with an extra little tiny hook on each one. And then I thought it would be interesting to activate it again. So you're just cutting and pasting and plugging your end geometry into the new geometry and then bringing the other one down. So technically, I'll do this a little easier. I'll move this one up, following that script about there. I'll take these guys and put them about here. And then I take another iteration, enable that one on. And this is doing what most of the recursion formulas do. Move that one up into here. Sorry for being a little clumsy. And then you've got a boundary representation that's all Boolean union from here to here. And even though I can show those two, I don't really need to at this point. Turn off preview and you've got your final form. So basically I've just done a recursion by putting 1, 2, 3 on it and run the system a few times, scaling it smaller. The only problem with this is I was kind of hoping I could go in and play with, but obviously the orientation doesn't place these exactly where they are when they don't follow the same kind of scaled pattern. Anyway, it's a long script, but it looks longer. All you'd have to do is pull in one of the plugins for recursion. You could avoid all this part of the script, and then you would just run this script as many iterations as you want to end up generating how many you want on here. And I'll just get rid of this other preview because we don't need that. And all those little guys should disappear. Preview off. And we're freezing up a little bit. There we go. And then I can just leave that as the final device. So that's a little clumsy, but like I said, I just want to show the basics and what kind of logically is happening. And I thought the script would allow us to see where a concise script could function with recursion tools and iterations without avoiding this kind of making of script again and again. But that's basically what's happening in recursion. We call upon the function itself again and again and again. And there you go. Got a pretty cool form and not bad. I'm not going to run any animation with it because it's kind of slow, but I don't know. It does make for some pretty interesting patterns and forms. And I'm just going to grab my little artistic tool because I'm a sucker for it and see what pops in here. Actually, I thought I grabbed Arctic. I always grabbed Arctic. Yeah, there you go. Ooh. Grasshopper tool, and that's without the final bake. And of course, you can just do the bake from Bakehand. There you go. And you can leave that one. There you go. And take that off. There you go. A pretty cool little form. And you can see that in its pen, in its technical, but also you'll notice that they don't really fuse. I built them so they sit on top of the surface and have gaps in between them. And the reason I've done that is because if you were to fabricate each one of these units, you'd still have to weld in, or you'd have to have some type of adhesive that would fuse that onto it. So it gives you a sense of the extra space. And like I said, I'm also trying to do programs that are tending towards physical fabrication of what you end up having to make. But a nice example of that. Long video, 7.5 minutes. Thank you for watching.